This is SpaceTime, Series 28, Episode 45. Coming up on SpaceTime. Why does the lunar far side have less water than the near side? Asteroid 2024 YF4, which came to fame after it was designated a possible Earth impactor earlier this year, now appears to be targeting the Moon. And how singing stars expose their galactic past. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Lunar rocks collected by China's Chang'e 6 sample return mission suggest that the Moon's far side is far drier than its Earth-facing side. The findings, reported in the journal Nature, add to the intriguing dichotomy between the Moon's two faces and offer potential new insights into lunar evolution. The analysis of Mare basalts are showing scientists the lunar far side's mantle contains far less water than on the near side. Over the past 2 decades, extensive studies of lunar samples from near-side rocks have demonstrated a highly heterogeneous distribution of water in the Moon's interior. Concentrations range from roughly 1 to 200 micrograms per gram. But the new data from the far side indicates water concentrations there are just 1 to 1.5 micrograms per gram. Notably, the crust exposed on the surface of the Procellarium creep terrain on the lunar near side has a higher thorium concentration than the other 2 primary lunar geochemical provinces, the feldsporitic highlands and the South Pole Aitken Basin on the lunar far side. The thing is, both thorium and water are considered incompatible elements during magmatic processes, meaning they preferentially remain in the melt rather than becoming incorporated into the crystallizing materials. This geochemical behaviour suggests that the mantle beneath the South Pole Aitken Basin may contain lower abundances of water. Now, to confirm this hypothesis, the authors focused on analysing water content and hydrogen isotopes in melt inclusions and apatite within the Chang'e 6 Mare basalt samples, which were the first lunar rocks returned from the far side. The results indicate that the parent magma of these basalts contain 15 to 168 micrograms per gram of water. The authors estimated that the mantle sourced to the Chang'e 6 basalts had a water content of 1 to 1.5 micrograms per gram, significantly lower than for the near-side mantle. Now, this disparity points to a potentially hemispheric dichotomy in the Moon's interior water distribution, and that mirrors many other asymmetrical features observed on the lunar surface. The new estimates of the lunar far side mantle's water content marks a significant step forward in refining science's understanding of the bulk silicate lunar water content. It provides important constraints in the giant impact hypothesis of the Moon's origin and underscores the role of water in the Moon's long-term evolution. This is SpaceTime. Still to come. Asteroid 2024 YF4, which came to fame after it was designated a possible Earth impactor earlier this year, now appears to be targeting the Moon, and how singing stars expose their galactic past. All that and more still to come on SpaceTime. Asteroid 2024 YF4, which came to fame after it was designated a possible Earth impactor, now appears to be targeting the Moon. The widely spinning 60-metre-wide space rock was discovered back on December the 27th last year, just a few days after Christmas, with early observations suggesting a possible collision with the Earth on December the 22nd, 2032. Now, of course, that was based on very early orbital data. NASA and the European Space Agency placed the odds of a direct impact with the Earth as high as 3%. And this potential threat quickly gained international attention among the public and media. The thing is, the figures were still based on very early tracking of the asteroid's orbit. And as more and more detailed observations came flooding in over the following weeks earlier this year, including studies by the European Southern Observatory's VLT, the Very Large Telescope in Chile, those risks eventually began dropping and dropping and dropping until they eventually became negligible. Asteroid 2024 YF4 was no longer likely to hit the Earth. But as the risk to Earth diminished, the chances of a collision with the Moon began to grow. In fact, it's now standing at 3.5%. And that makes YF4 one of the largest objects in recent history that could impact the Moon. Meanwhile, as this near-Earth asteroid continues moving away from the Earth-Moon system on the outward leg of its 4-Earth-year journey around the Sun, astronomers using the Gemini South telescope in Chile examine the rock in multiple wavelengths, creating a three-dimensional image showing that it's shaped more like a flat disk, a bit like a not-quite-round hockey puck, rather than a potato, which most asteroids look like. They also discovered that it was tumbling at a rate of around once every 20 minutes. And astronomers using the Mossfire spectrograph on the Keck Observatory on Mauna Kea in Hawaii were able to determine the physical properties and potential origins of YF4, revealing it to be a solid, stony S-type asteroid rich in silicates that likely originated from an asteroid family in the main asteroid belt between Mars and Jupiter. The findings have been reported in the Astrophysical Journal Letters and on the pre-press physics website archive.org. This is SpaceTime. Still to come, how singing stars expose the galactic past. And later in the science report, there's been a lot in the news about the extinct dire wolf being resurrected through genetic engineering. But how true really are those claims? All that and more still to come on SpaceTime. Astronomers studying the open star cluster Messier 67 have used stellar seismology to help them determine how the stars in the cluster have evolved over cosmic time. The findings, reported in the journal Nature, are allowing scientists to map the history of the Milky Way and other galaxies, accelerating knowledge in the field of astrophysics. Located some 2,700 light-years away and containing some 1,080 solar masses, Messier 67 is one of the best-studied star clusters, yet estimates of its physical parameters, such as its age, its true mass, and the number of stars it contains of a given type, vary substantially. What is known is that the stars in this cluster were all born at the same time from the same molecular gas and dust cloud, with the best estimate suggesting about 4 billion years ago. Now, that means any differences between individual stars in the cluster must be due primarily to their stellar mass. Now, from what astronomers can tell, M67 has around 500 stars, including at least 150 white dwarfs and more than 100 sun-like stars, as well as numerous red giants. These are evolved stars which have moved off the main sequence. That's where stars are burning hydrogen into helium in their stellar cores. The ages and prevalence of sun-like stars in the cluster has led some astronomers to hypothesize that it's possible that this could be the stellar nursery of our own local star, the Sun. However, computer simulations disagree on whether our solar system would have survived an ejection from M67, and the cluster itself would probably not have survived such an ejection event anyway. The cluster now contains no main sequence stars bluer than spectral type F white stars. That's because any brighter stars of that age would have already left the main sequence. In fact, when stars in the cluster are plotted on the Hertzsprung-Russell diagram, there's a distinct turn-off representing the stars which have terminated hydrogen fusion in the core and are now destined to become red giants. But that's not unusual. You see, as a cluster ages, the turn-off moves progressively down the main sequence towards cooler stars. That's because hotter stars burn through their nuclear fusion process quicker, while cooler stars, like our Sun, tend to live much longer. The study's lead author, Claudia Reyes from the University of New South Wales, studied 27 of the stars in the cluster to better understand how stars of different masses but similar compositions have evolved differently. Reyes says while these stars are all the same age, it's their mass which gives away how quickly they've evolved. The study also opens new ways to learn more about what the Sun will do as it gets bigger and older. The thing is, verifying the age of a star is one of the most difficult things you can do in astronomy. That's because the age of a star isn't revealed by its surface. It's what happens inside that shows astronomers how old a star really is. Reyes and colleagues were able to precisely determine a star's age based on its oscillation frequencies, basically how the star vibrates, how it rings, and that depends on the physical properties of the matter inside the star. It gives clues about stellar density, temperature, and age. This is the first time researchers were able to interrogate the ringing across a cluster of stars in order to learn more about their internal structure. To do this, They use data from the Kepler K2 mission as a primary way to observe or listen. Reyes says the process is a bit like listening to an orchestra and identifying instruments based on their sound. The frequency by which an instrument's vibrating or ringing depends on the physical properties of the matter that the sound's travelling through. That's why a violin doesn't sound like a grand piano. And it's the same for stars. And we can see that vibration, or the effects of that vibration, that is the sound, just like you can see the vibration of a violin string. The bigger stars have the deepest sounds, while smaller stars have more high-pitched tones. But of course it's not that simple. No one star plays just one note at once. Each star has a complete symphony of sounds coming from its interior. And these sounds exist as waves of energy, a vibration moving through particles, solid, liquid or gas. Reyes says each star is like a breathing ball of gas, cooling down and heating up, causing slight changes in its brightness. And it's these fluctuations in brightness that Reyes and colleagues were watching for and then measuring in order to gauge the sound frequencies. As stars in the main sequence mature towards the red giant phase, their frequencies change and they behave differently, and these changes can help track their evolution. The frequency differences between the many modes played by the star can give clues about its interior properties. And by studying 27 stars in the M67 open cluster, the authors could for the first time observe the relationship between small and large frequency differences in giant stars, and that can now be applied to individual stars. You see, to better understand the formation and evolution of galaxies, scientists need to know the ages of all its components, including the stars. Reyes says the study will lead to an accurate identification of the mass and age of stars in the Milky Way, something yet to be achieved.
We have found that the seismology of stars can give a different tool to get the ages, and it is way more precise than traditional methods. So what we do is we use the oscillations of stars that have convective envelopes to measure the frequencies at which they resonate. And we then compare those frequencies with the models that we have, and we can estimate very good masses and ages. We know in the spectral diagram where the stars that have convective envelopes lie. So our sun is a very good example of that, but also most of the giant stars. So we target those, and we observe the very small variations in their brightness. And then we observe them for a long time, as long as possible, but we are limited, of course, by telescope capacities. But then we take those light curves and we transform them into the frequency space. And that's what the oscillations that we measure come from.
And you use that to calculate stellar age, stellar evolution.
That's right, because we have very good models, and our models actually can predict very accurately where every one of those frequency peaks will lie in a frequency spectrum.
Why did you choose M67?
M67 is a very special cluster for a number of reasons. One of them is that it has very similar to solar composition, which is very good because our models are best calibrated to the sun normally. So another good reason is that it is not very obscured by dust. We have a good look at those stars. And another good reason is that it is very well populated. So from the main sequence from lower evolutionary phases until the later evolutionary phases, we have an amazing sample of stars that we can observe very clearly.
You knew they all formed in the same molecular dust cloud, so they had a similar composition. You knew they started out at roughly the same time, so they're the same age. And by looking at how stars of different masses evolved, you were able to fine-tune your hypotheses.
Exactly, because we know that the difference between two of them is mostly related to the mass that they started with. So it's not related to any other factor like chemical composition or distance or dust or anything like that. So yes, we can observe the entire sequence of frequencies, and basically it's the next best thing as to just following a star for billions of years and seeing how it evolves. Of course, we cannot do that, but we can look at this very nice sequence of stars.
And this will allow you to get a better understanding of our sun as well.
Yes. So the stars that we particularly target in this study are stars that are more evolved than the sun, which is like looking into our sun's future. So what we learned from this study, one of the things that we learned is that we have evidence of how deep that convective envelope will actually reach. So we have predicted this, and we have indirect methods of getting this information of how deep the envelope actually reaches. And now we have very direct indication of the depth of that envelope, and it is what will happen to the sun.
Is our schedule of the sun accurate at this stage?
So what stars do, including our sun, when they run out of hydrogen in its core, they begin to puff up. So as the core will become even more dense, its outer layers will become more expanded. And yes, they will reach where the radius where the Earth is located, but it is so far in the future.
But a lot sooner than that, as the sun continues to heat up, a lot sooner than that, the Earth will become uninhabitable anyway. Or at least that's the hypothesis that I was taught.
Yeah, well, before the Earth is engulfed by the sun, yes, it will become uninhabitable. But the sun has a good billion of years in its current state, so nothing will happen for a long time.
Starquakes, tell me about them.
So starquakes are very similar to earthquakes that we are familiar with, just that they happen in stars. But the cause of the quakes are different. So, for example, in the Earth, we are familiar with the tectonic plates running into each other. That is what causes these earthquakes. In stars, they have this bubbling outer layer of gas.
It's like water boiling in a pot.
I think so. Yeah. So what happens is that convective envelopes need to transport energy from the core to the surface very efficiently so that stars can keep from collapsing, right? So these bubbles, when they reach the surface, they burst. And by bursting, they send ripples through the entire star. And that is what causes the starquakes. And I think it's really fascinating that we can learn so much from that.
And does magnetism play an important role in this? Because we know that things like coronal mass ejections and stellar flares are triggered by magnetic ropes that are being twisted as the star rotates at different rates. Does that play a role in this, or is that independent from percolations of plasma that lead to starquakes?
Yeah. So the study of magnetism using seismology is a very active. And one thing that it does that is really interesting is that the magnetism in the core of a star can actually suppress that oscillations and leave us with a partial power spectrum. So that is one of the areas where magnetism can be observed in astroseismology.
And where would you like to take this research to next?
It's very interesting because this research, other than let us know a lot of what is going on underneath the outer layers of the stars, as it is one of the main outcomes of this study was to find out specifically when the outer layer reaches this greater depth. So the other outcome of this study is that we can get even more precise ages for a particular subset of stars everywhere in the galaxy, not only in the cluster M67. So next for us is to look for stars in these particular phases everywhere in the galaxy, so we can then use that data for galactic archaeology, which is the search for reconstructing the history of the galaxy.
That's Claudia Reyes from the University of New South Wales. And this is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. 2 new studies have linked diabetes drugs such as Ozempic, which lowers blood glucose, showing it may also lower the risk of Alzheimer's and dementia. A report in the Journal of the American Medical Association found that one study looked at Alzheimer's diagnosis in patients taking a class of drugs that includes glucagon-like peptide-1 receptor agonists, GLP-1 RAS, and another class of glucose-lowering drugs known as SGLT2IS. They found that patients taking the newer drugs had lower rates of Alzheimer's disease and other dementias. Meanwhile, the second study pulled together the results of previous clinical trials, finding that GLP-1 RAS, but not SGLT2IS, were associated with a reduction in dementia or cognitive impairment. The company behind efforts to resurrect the woolly mammoth, the thylacine and the dodo now claim they've achieved what they're describing as the de-extinction of the dire wolf. It's a species that went extinct about 10,000 years ago. Colossal Biosciences claim it's produced 3 very cute little puppies named Romulus, Remus and Khaleesi based on genetically engineered grey wolf genomes. However, according to Professor Philip Seddon from the University of Otago, grey wolves and dire wolves, despite the wolf part in their names, aren't closely related, having parted ways from a common ancestor some 6 million years ago. In fact, he says the African jackal's probably more closely related to real dire wolves. The company simply introduced a series of genetic changes to a grey wolf to produce grey wolf pups with dire wolf features, such as paler coats and potentially a slightly larger size. A new study shows that farmers had been transporting fish up into the Pyrenees Mountains between modern-day Spain and France and into local Pyrenees waterways and lakes as early as the 7th century. A report in the journal Nature Communications found that lakes in the highest mountains of Europe didn't originally have fish, but evidence of people introducing them to these areas has been found dating from the 14th and 15th centuries. The authors studied a sedimentary core in Lake Redon in the Spanish Pyrenees, finding data from fish parasites and fish prey dating back to the early 7th century, a time when the region was likely used for sheep farming. And that suggests that fish must have been brought there earlier than previously thought. Of course, today this lake is home to about 60,000 brown trout, descendants of those original fish transported up by early farmers. There's a growing spread of misinformation online about the nutritional value of various supplements. But Tim Mendham from Australian Skeptics says it's possible to protect yourself and tell the difference between what's good advice and what's not if you follow some simple rules.
Nutrition, especially online recommendations for nutrition, you go through your TikToks and all that sort of stuff, is fraught with bad information, bad advice from people who really don't know what they're talking about. And wellness influencers are the people who often up there use this product and, stick your mouth full of cinnamon or whatever, or take the big one with apple cider vinegar, which will cure anything going, apparently. All these things are recommended. You go online, you see these things everywhere. This will guarantee the cure you of this particular problem.
I remember when echinacea was a big thing. Everyone had to take echinacea.
Yeah, echinacea was that's not a homeopathic treatment, it was a herbal treatment, supposed to cure you for colds. The fish oil, it was largely overstated about sort of what it could actually do for you.
And there are also concerns about its quality and how old it is and how well it's...
Quality is especially a problem, that you don't know how it's made and how true it is. I mean, despite what it says on the label, that's not necessarily a guarantee, especially if it's taken as a food supplement, not as a medicine thing, because the medicine things are more closely reviewed, hopefully. The food things are less closely reviewed, except if they're poison, right? There's a big overlap there between what's a good diet or a nutritional product rather than a medical product. And that's part of the problem, is that in many cases the nutritional product is regarded as food, and that's a different authority to the medical regulatory bodies. So what you have is that with nutrition, anyone can get, actually it happens with medicine as well. So people get online, they go a TikTok, a 3-minute video about, use this thing, it's worked for me, and I've got this great body, etc. And you too can have this if you take this product.
I had a great body once, but I had to give it back.
Yeah.
Okay, back to our story.
So the thing about a lot of this stuff is that obviously you've got to take it with a grain of salt, that's metaphorical. But the global dietary supplement industry is not some little thing. It's worth globally about 150 billion US. So people talk about big pharma, etc., but they should talk about big supplement or big homeopathy or big nutrition, etc. This is a giant industry made up of lots of little different things, and some of them major, some of them tiny, some of them promoted by one person on TikTok, others promoted by organisations that we hope would know better. But how do you tell? That's hard, actually, because a lot of these people are very convincing. They've got confidence. They will use anecdotal evidence, which is not worth very much.
And a lot of them employ doctors, trained medical practitioners, practitioners to spruik their claims.
Yes, unfortunately, you'll always find some qualified person to promote any particular pseudoscience, pseudomedicine. Yeah, the things to do, first of all, check your reasoning for trying to follow this. Is it fear? Is it anger? Why are you paying any attention to this at all? That's a bit of a hard one to do. Next, check who's saying it. Do they have qualifications? Do they know what they're talking about? Are they lying? But then if you say you can get a medical doctor to endorse something anywhere, and then try and find some critical reviews of this thing. And my advice, I've found in my experience, is that if you say, for instance, apple cider vinegar, Google in apple cider vinegar skeptic. Right? You add the word skeptic and you'll find alternative views. So check your motivation, check the authority, and check the facts, and you discover a lot of weird things.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. Or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.